This lecture discusses distribution shapes. The distribution of a dataset is a table, graph, or formula that provides the values of the observations and how often they occur. For a table, for example, a frequency table of qualitative data. For a graph, for example, a relative frequency histogram. This histogram shows the relative frequencies for the height of 3,264 female students who attend a Midwestern college. We can see that the values range from roughly 56 to 74. It has one peak around 64 or 65. The shape is roughly symmetric. This shape is called a bell shape. When describing the shape of a distribution, we may use words such as modality, uh, symmetry, and skewness. The word modality means the number of peaks. The first plot has only one peak, and it is a unimodal. The second plot has two peaks, and it is bimodal. The third plot has three peaks, and it is multimodal. The second row shows some common shapes for symmetric distribution. The first one is bell-shaped. It is a common shape in practice. The second one is triangular shape. The last one is uniform, or a rectangular shape. The first two plots in the bottom row show two skewed distribution. The first one is right skewed because it has a long tail on the right. The second one is left skewed because it has a long tail on the left. The last one is called reverse J-shaped. It is a decreasing function, which means the larger the value, the smaller relative frequency. Many data on lifetime have this shape. For example, the life of a person. When the larger the age, the smaller percent of person can live to that age. This is an example showing the relative frequency histogram for household size in the United States, based on data obtained in current population reports. Because we describe the shape of a distribution, we usually try to add a smooth curve to capture the trend of the histogram. It is greatly helpful when trying to identify the shape of a distribution. We can see that the values range from 1 to 7. This histogram has only one peak, so it is unimodal. Clearly, it is not symmetric. It has a tail on the right, so we may say that it is right skewed. We have discussed before population and sample. Population data means the values of a variable for the entire population. The distribution of population data is called a population distribution, or the distribution of the variable. Sample data means the values of a variable for a sample of the population. The distribution of sample data is called a sample distribution. For a simple random sample, the sample distribution approximates the population distribution. Clearly, the larger the sample size, the better the approximation tends to be. This slide shows the distance between a population distribution and a sample distribution. The first histogram is based on the whole population. The remaining 6 histograms are based on 6 different samples from the population. We can see that each sample distribution looks similar to the population distribution. However, they are not identical. There are also some small variations. Different sample distributions are also similar but not identical. This illustrates that it is possible to approximate population using a sample because they have the same distribution.